Why are analog inputs so important in the world of robotics? That's a question that could lead us down many intriguing pathways. Analog inputs for robots are signals or data representing continuous and fluctuating quantities, not just discrete binary states. They can take on a plethora of values within a specified range, offering more nuanced and detailed information about the environment. These inputs are instrumental for robots to sense, measure, and interact with variables such as position, force, temperature, and more. Imagine a world of robotics without analog inputs. It would be like trying to paint a masterpiece with only two colors. Analog inputs bring depth, detail, and a spectrum of possibilities to the robotic world. So what types of analog inputs are used in robotics? First off, there are position sensors. Potentiometers, or variable resistors, provide an analog voltage proportional to the position of a movable part, such as a robot joint. Then we have analog encoders that produce varying voltage signals as a function of rotation or position, allowing precise measurements of angles. Next, consider force or torque sensors, which provide analog readings that indicate the force or torque applied to a robot's end effector or manipulator. These sensors enable tasks like safe object manipulation. Analog pressure sensors measure fluid or gas pressure and provide an analog voltage or current output proportional to the pressure. Analog temperature sensors, such as thermistors or thermocouples, produce varying voltage levels based on the temperature they sense. Light-dependent resistors or photodiodes produce varying resistance or voltage based on the amount of light they receive, while analog cameras produce continuous voltage signals that represent the intensity of light at different points in an image. Strain gauges detect deformation in structures and materials by measuring changes in resistance. The analog output can be used to assess structural integrity. Voltage sensors, on the other hand, measure electrical voltage levels and provide analog output to monitor power supply conditions. Analog distance sensors provide voltage outputs that vary according to the distance between the sensor and an object, while analog gas sensors measure the concentration of specific gases in the environment and provide varying analog outputs. But what happens to these analog signals? They are converted to digital signals using analog to digital converters before being processed by the robot's microcontroller or control system. This conversion process involves discretizing the continuous analog signal into discrete digital values that can be easily manipulated by the robot's algorithms. In summary, analog inputs provide robots with the ability to sense and respond to a wide range of physical phenomena. They contribute to the versatility and adaptability of robots in various applications, making them invaluable tools in our technologically advancing world. Without analog inputs, the world of robotics would lose its depth and nuance, reducing its ability to interact effectively with its environment.